What happens when the universe itself seems to send a question in the form of stone and ice? In the endless stillness between stars, patterns usually hold. Gravity bends. Light stretches. Galaxies spiral in their ancient turns. Stars collapse into silence. Black holes swallow matter whole. Even in its violence, the cosmos obeys its laws with a kind of solemn order. Yet into that balance has come a fragment that refuses to obey. Astronomers have named it 3I Atlas, the third known interstellar object to enter the dominion of the Sun. But unlike those that came before, this one behaves as if the script of nature has been torn and rewritten. Its trajectory curves with disobedience. Its brightness fluctuates in ways that resist easy calculation. To scientists watching from Earth, it feels less like a visitor and more like a riddle that refuses to be solved. And so the question deepens. Is this chaos an accident of broken rock hurled blindly across the abyss? Or is the universe revealing a side of itself that had remained hidden until now? Space is not silent when something like this occurs. It hums with unease. A messenger has arrived, bearing no words, only movement. A shard older than the sun, wandering into our system as though to remind humanity of how little it truly knows. If the cosmos is speaking through 3I Atlas, what is it trying to say? A secret long buried in the dust between stars, or a warning written into its unpredictable path? The universe has not given an answer. Only a mystery. From the deep silence of the outer dark, a fragment approached. It carried no sound, no message, no declaration of origin, only motion, only light, only the unmistakable curve of its orbit across the emptiness. It was April of 2020 when astronomers first glimpsed it. Their tools were not ancient stone circles or fragile brass instruments pointed at the heavens. They were the Atlas telescopes of Hawaii, the asteroid terrestrial impact last alert system. Machines designed not for poetry but for survival. Their mission was clear: to watch the skies for threats to Earth, to catch the faint glow of objects that might one day collide with the fragile sphere of human life. And yet, what they found was not a near-Earth asteroid at all. It was not a familiar traveler from within the sun's reach. Its trajectory told another story. Its speed, its angle, its very path revealed the truth. This was not born of the solar system. It was an intruder, an interstellar wanderer, the third of its kind ever detected. And so it was named 3I Atlas. The name carried weight. The 3I marked it as the third interstellar object. The suffix Atlas tied it to the eyes that had first seen it. But names are thin veils. What mattered was what it represented. A shard from elsewhere. A visitor from the deep between stars. A messenger older than the planets themselves. Before Atlas, there had been two others. Oumuamua, discovered in 2017, had shocked the world. A thin, elongated fragment tumbling like a shard of fractured glass, it moved in ways that resisted easy explanation. It had no cometary tail, no plume of evaporating ice, and yet it accelerated as though pushed by some unseen hand. Scientists debated, outgassing too subtle to detect or something stranger still? Oumuamua slipped away before the answers could be found, leaving only speculation in its wake. Then came 2I Borisov in 2019, a comet-like body discovered by an amateur astronomer, Gennady Borisov. Unlike Oumuamua, this one was less enigmatic. It bore the familiar signatures of a comet, shedding dust and gas as it passed the sun. Yet its velocity and trajectory confirmed it too was from beyond. A fragment of another planetary system, drifting through the Milky Way, caught for a moment in the light of humanity's telescopes. But 3I Atlas was different. More unstable, more haunting. Its orbital path bent steeply through the solar system, with an inclination of nearly 46 degrees relative to the plane of the planets. Its hyperbolic velocity, around 30 kilometers per second, declared its origin without question. No gravity of the sun could hold it. Its fate was not to circle endlessly, but to cross through, to pass on, to return to the interstellar dark. Yet it was not merely its speed or its inclination that unsettled astronomers. It was the way it behaved. Brightness that flared and dimmed unpredictably, fragments of its structure seeming to shift and separate, an object already unstable, already breaking apart, as if it had been torn in some ancient violence long before it reached Earth's gaze. Estimates placed its size between a few hundred meters and perhaps half a kilometer in diameter, a body smaller than a moon, larger than the monuments of human civilization, yet carrying with it a mass of mysteries. Its brightness anomalies suggested fragmentation, the shedding of dust and ice, perhaps even internal stresses cracking it from within. Some models suggested it may have disintegrated entirely before leaving the system, its pieces lost into the void, but its instability raised deeper questions. Oumuamua had defied expectations by accelerating without a clear mechanism. Borisov had been a comet, predictable in its behavior. Atlas seemed to occupy a strange space between them, neither stable comet nor silent rock. Instead, something fractured, something unraveling, something that refused to fit comfortably into the categories of human science, and so the pattern deepened. 3 visitors, 3 stories. The scout, the comet, the broken shard. Together they whispered of a truth larger than any single object. That the void between stars is not empty. It is seeded with fragments, relics of worlds unseen, pieces of planetary systems shattered and scattered across the galaxy. Each one older than human civilization, older than Earth itself. For astronomers, these objects were more than curiosities. They were messengers of origin, a chance to study material not born of the sun but of distant stars. In them lay the potential to glimpse other chemistries, other planetary formations, other cosmic histories. And yet each had been fleeting. Oumuamua slipped past too quickly. Borisov fragmented as it neared the sun. And now Atlas arrived already unstable, already disintegrating. As though the universe allowed only glimpses, never answers. The philosophical weight was heavy. What does it mean that fragments from other worlds drift into ours? What does it mean that they carry with them riddles instead of clarity? To some it was humbling, a reminder that Earth is not the center, but a particle adrift in a sea of unknowns. To others it was haunting. If visitors arrive bearing no clear signature, how many others have passed unseen? How many more fragments slip by in silence, their trajectories unmeasured, their presence undetected? The Atlas system had fulfilled its role. It had seen what others had missed. Yet detection was only the first step. Interpretation was far harder. Telescopes strained to follow the fading light of 3-eye Atlas as it broke apart. Papers filled with models and conjectures. Theorists debated whether its origin lay in the icy outskirts of some distant star, ejected by a gravitational dance of planets, or whether it was the fragment of a shattered world, hurled into space by catastrophe. Some speculated its disintegration was not a sign of weakness but of history, that it carried scars from encounters long before it reached this system, that in its instability lay the memory of a violent past. Others reflected on what such visitors truly reveal. Humanity has always looked outward with a desire to understand. Yet the universe often answers not with clarity but with mirrors. Each interstellar visitor has forced humanity to confront its own limitations, its brief perspective, its fragile grasp of cosmic truth. Atlas, breaking apart as it crossed the sun's light, was a symbol of impermanence. A body older than Earth itself, yet fragile enough to dissolve in the warmth of a single star. What greater metaphor could there be for existence? To endure eons in silence, only to unravel when passing into illumination. The telescopes recorded its light until the fragments grew too faint. Its path was calculated, traced, archived. It entered, it crossed, it left. The cycle was complete, and yet even as its remains vanished, questions endured. Why do these interstellar wanderers arrive at all? What timing, what accidents, what celestial alignment send them into the reach of human eyes? Is it random chance, or is there a deeper order at play? Science provides no answers beyond probability. Objects are ejected from planetary systems by gravitational chaos. They drift for millions, even billions of years. A few by chance intersect the sun's sphere of influence. Most pass unnoticed. A rare few are caught in the light of human instruments. But philosophy lingers where data ends. If these visitors are random, they are reminders of a vastness beyond comprehension. If they are part of a deeper pattern, they hint at a structure to the cosmos yet unseen. In either case, humanity is left small beneath their shadow. The Atlas was more than a piece of rock and ice. It was a symbol, a shard from beyond breaking apart in a system not its own. A visitor whose arrival told of distance, whose disintegration spoke of fragility, whose departure left only reflection. For in its brief passage, it reminded humanity of something essential. That the universe is alive with movement and mystery. That every star, every planet, every fragment tells a story. And that in the end, the cosmos is not a stage upon which Earth stands alone. It is an ocean, and humanity is but a ripple upon its surface. And so the arrival of 3i Atlas was not merely an event. It was a moment, a mirror, a question, a reminder that the unknown is not far away, but ever present, drifting through the very space humanity calls home. In the great silence of interstellar darkness, there is comfort in law. Gravity holds, orbits follow, motion bends along curves dictated by mass and distance. The cosmos, for all its violence, unfolds with precision. Stars collapse in patterns understood. Planets spin with obedient rhythm. Even comets, fragile, unpredictable at times, still obey the rules of thermodynamics and light. But then, 3i Atlas shifted. What the astronomers saw was not gentle drift. It was not the slow and predictable arc of a comet growing a tail in the warmth of the sun. It was something sharper, more violent, as though the object itself had rebelled against order. Its brightness surged unexpectedly, flaring in a sudden eruption of light. For a moment, it was magnitudes brighter than models predicted. Then, as quickly as it had come, the light dimmed again, vanishing back into near obscurity. The change was not merely in brightness. Its path itself seemed altered, as if fragments were breaking away, redistributing momentum, leaving behind the echo of something tearing itself apart. Instruments on Earth and in orbit strained to capture data. Photometric curves bent wildly, showing the fingerprints of an object in crisis. The universe, usually so slow to reveal change, was suddenly a theater of chaos. Scientists proposed explanations rooted in known physics. One possibility was sublimation, ices within the object vaporizing as sunlight touched them. This is how comets live and die, shedding tails of gas and dust as they approach a star. Yet Atlas's outburst did not match the profile of a comet. The brightening came too fast, too intense, too irregular. A comet flares as layers of ice heat and release, but Atlas seemed to fracture, to erupt, as if its structure had been unstable long before it ever entered the solar system. Others suggested tidal stresses, the pull of gravity stretching it, cracking it from within, a world shattered by distant encounters, its scars now revealed under solar light. Some models compared it to the disintegration of comets like Shoemaker-Levy 9, torn apart by Jupiter's gravity before slamming into its atmosphere in 1994. But Atlas was not within reach of any giant planet's crushing field. Its disintegration happened in open space under no such grasp. The anomalies deepened. Spectral analysis hinted at dust and volatile material, but in unusual proportions. Its fragments behaved erratically, expanding not as a single tail but as irregular clouds, as though entire pieces had fractured away. Observers described it less as a comet unraveling and more as a body collapsing under the weight of its own history. What history could that be? Perhaps it had wandered near another star before. Perhaps its passage had already fractured its core, leaving it brittle and unstable. Or perhaps the violence was older still, born from the shattering of a parent world. a planetary collision in a system long gone cold, sending its fragments into exile across the galaxy. The insane shift, as some astronomers quietly called it, was more than an anomaly. It was a rupture in expectation. It challenged the neat categories into which science places cosmic debris. If 3I Atlas was a comet, it did not behave as one. If it was an asteroid, it was far too volatile. If it was something between, it resisted clear definition, and so the metaphor of chaos emerged. In physics, chaos is not mere disorder. It is sensitivity. It is the dependence of outcomes on conditions so delicate that prediction becomes nearly impossible. A grain of dust shifts and the pattern of the whole system changes. Atlas seemed to embody that principle, its instability magnified with each observation. Its flares of light, its sudden dimming, its altered path, all echoed a system on the edge of comprehension. But the chaos was not only physical, it was existential. For centuries, humanity has looked to the heavens for signs of permanence. The stars were fixed. The planets circled with clockwork grace. The night sky was a canvas of certainty against which human lives played out. Yet in moments like this, the illusion fractures. The universe reveals not order, but volatility. Not stability, but upheaval. Atlas was a reminder that even the fragments drifting between stars can surprise, disrupt, overturn. The cosmos is not a polished machine. It is a sea of turbulence, a theater of collisions and unraveling bodies, where even stone and ice carry within them the memory of violence. Some theorists suggested the flare might have been triggered by super volatile ices, compounds like carbon monoxide or carbon dioxide that sublimate far more rapidly than water ice. If true, it would imply that Atlas carried material from the coldest edges of its parent system, a relic from a frozen birthplace. Others speculated about rotational breakup, that its spin, accelerated over time by outgassing, may have torn it apart from within. Both models were grounded in known physics, yet both carried the same unsettling truth. Atlas was falling to pieces before humanity's eyes, and with every fragment shed, the mystery deepened. Each anomaly forced reflection. If even small interstellar objects are this unstable, how many of them cross unseen? How many crumble before they ever reach a telescope's gaze? If Atlas is a shard of a larger body, how vast was the catastrophe that created it? What ancient violence seeded the galaxy with debris, fragments wandering billions of years before reaching this system? The moment was humbling. The laws of physics had not been broken, but their manifestation was stranger than expected. Humanity's categories, comet, asteroid, interstellar rock, seemed insufficient. The universe, it seemed, was reminding its observers that reality is not bound by human words. It obeys deeper laws, laws that unfold with a complexity beyond immediate comprehension, and so the insane shift became more than an astronomical report. It became a symbol. The sudden flare of brightness, the collapse into fragments, the unpredictable course, all mirrored the fragile balance of existence itself. A reminder that what appears permanent is often brittle, that even bodies that endure millions of years can unravel in a moment. The telescopes of Earth traced its decline with patience. The data streams filled with light curves, orbital adjustments, fading signals. To scientists, it was an opportunity. Each anomaly was a clue, each fracture a chance to learn. Yet even as the models grew, the mystery remained larger than the answers. In the stillness of cosmic time, events like this are rare. To witness one is to stand on the edge of understanding, to glimpse turbulence written across the stars. The insane shift of 3I Atlas was not simply a cometary disintegration. It was a rupture in expectation, a reminder of the universe's volatility, a whisper of chaos from the deep. And beyond the data, beyond the models, lay a question that lingers still. If such objects wander freely, shifting with instability, what might larger ones do? What histories do they carry? And what truths might they reveal if ever their paths cross more closely with the fragile orbit of Earth? The cosmos, it seems, is not silent. It speaks in eruptions of light. It speaks in fragments that tumble into the dark. And sometimes it speaks in chaos, reminding humanity that the order it seeks is only one side of a much greater truth. In the beginning, astronomy was the language of order. The planets moved in patterns so precise that early civilizations carved their rhythm into stone. The stars returned each season with faithful regularity. The moon waxed and waned with a rhythm as ancient as life itself. To look upward was to find constancy. The night sky was a mirror of eternity, a vast geometry that promised permanence. Yet within that geometry lies chaos. Chaos, in the scientific sense, is not disorder. It is sensitivity. It is the truth that even the smallest influence applied in the right place can cascade into transformations beyond prediction. A butterfly's wing in the air can alter the course of a storm. A grain of dust nudged by starlight can drift into a new orbit that, over millennia, redirects an entire asteroid. In space, chaos is everywhere. It is woven into the fabric of motion, a reminder that certainty is only ever temporary. Atlas was an expression of this truth. Its trajectory, so carefully calculated, carried within it an invisible fragility. A flare of sublimating ice, a faint tug of solar radiation pressure, a fragment breaking from its core. Each small change shifted the path, altered the spin, disrupted the expected brightness. Sensitive dependence on initial conditions. This is the heart of chaos theory. What begins as a whisper grows into a storm. What begins as a microscopic fracture becomes an object tearing itself apart. For astronomers, the mathematics is clear. Equations describe these sensitivities, mapping how orbital elements diverge over time. A body with even the slightest instability can, over millions of years, be transformed into something wholly unpredictable. In the solar system, comets and asteroids dance to this rhythm. They are perturbed by planets, nudged by outgassing jets, twisted by the subtle but relentless pressure of photons streaming from the sun. Solar radiation alone is enough to reshape a worldlet. Each particle of light carries momentum, and over long spans of time, that pressure alters orbits. Known as the Yarkovsky effect, this phenomenon can shift an asteroid across millions of kilometers. The cosmos, it seems, is sculpted not only by massive gravitational giants, but by the faintest touch of starlight. For 3I Atlas, the effects were magnified by its interstellar origin. This was not a body born of the sun's order, but a fragment already scarred by its journey. Its spin carried echoes of collisions with other debris. Its surface bore ices from a colder star, volatile and unstable beneath solar warmth. Even the faintest stresses were enough to unleash chaos. To understand this, scientists often invoke the language of ponds and ripples. Imagine a stone thrown into still water. The waves spread outward, intersecting, interfering, creating patterns both predictable and yet infinitely complex. Now imagine that pond is space-time itself, curved and bent by mass and energy, as Einstein revealed. Every fragment, every photon, every fluctuation ripples across that pond. The geometry of the cosmos is fragile, sensitive, alive with interaction. Einstein's relativity showed that space-time is not a static backdrop, but a dynamic fabric. Mass bends it, energy curves it. Time and space are not absolutes, but entangled. Within that entanglement lies instability. The orbit of Mercury shifts subtly, precessing because space-time itself is warped by the sun's gravity. Black holes bend not only light, but the very possibility of prediction. And into this fragile geometry wandered 3I Atlas, a stone cast into the cosmic pond. Its presence, small though it was, rippled outward in meaning. It disrupted not the planets or the stars, but the assumptions of those who watched. For if such a fragment could behave with such volatility, what other surprises lie adrift in the galaxy? Stephen Hawking often spoke of instability not as failure, but as the very engine of discovery. "Without imperfection," he once said, "you and I would not exist." The universe thrives on imbalance. Instability gives birth to stars, as clouds of gas collapse under gravity. Instability shapes galaxies as density waves carve spiral arms. Instability drives evolution, as chance mutations open new pathways of life. Chaos, then, is not the enemy of order. It is the companion, the twin, the shadow without which order cannot be defined. In the story of Three-Eye Atlas, this truth was manifest. Its sudden flares of light, its fragments scattering into space, were not evidence of failure, but of history. They revealed the fragility of bodies older than Earth. They revealed that chaos is not a disruption of the universe's laws, but the purest expression of them. Mathematicians describe chaos with strange beauty, strange attractors, fractal patterns, infinite feedback loops. Astronomers see it in the three-body problem, where the orbit of a planet influenced by two stars becomes unpredictable beyond a certain horizon. What begins as a solvable equation dissolves into turbulence. Prediction breaks down, not because the universe has no rules, but because the rules are too exquisitely sensitive to ever be perfectly mapped. And so, with Three-Eye Atlas, prediction gave way to wonder. Telescopes could trace its path for a time, but its fate was to dissolve, to scatter, to pass beyond calculation. It was the embodiment of chaos theory in motion. A fragment that entered with apparent stability, only to unravel under invisible hands. The metaphor is inescapable. Humanity itself exists within this fragile balance. Civilizations rise and fall under the influence of forces often unseen. Climate shifts with minute changes in orbit. A single mutation in a strand of DNA reshapes the destiny of a species. The cosmos and life within it are both products of sensitivity, of chaos written into the fabric of existence. And yet, within this turbulence lies meaning. To witness chaos is to be reminded that certainty is never guaranteed. To observe an interstellar fragment unravel is to glimpse the dynamic heart of the universe. Three-Eye Atlas was not merely an object breaking apart. It was a message carved in ice and dust. A reminder that the cosmos is alive with instability. That every trajectory carries within it the seeds of change. Astronomy, for all its precision, is also philosophy. The equations map orbits, but the meaning lies beyond mathematics. To see a body from another star dissolve before our eyes is to confront impermanence. To realize that even the cosmos itself is not fixed, but fluid, sensitive, ever-changing. In the silence of space, chaos does not roar. It whispers. In the flare of a distant fragment, it tells us that prediction has limits. That certainty is fragile. That the unknown will always press against the edges of knowledge. Atlas, in its insane shifts, embodied this whisper. A stone cast into the cosmic pond, rippling not only across space but across human thought. It left no clear answers, only turbulence, only reflection. And perhaps that is the truest gift of chaos, not to reassure but to remind. For in the end, chaos is not the absence of meaning. It is meaning itself, written in patterns too vast for the human eye to follow. It is the reminder that the universe is not a clock but a storm. Not a structure of steel, but a sea of currents. And in that sea, every fragment, every photon, every moment carries the possibility of transformation. Atlas has already vanished from the reach of telescopes. Its fragments drift into the black, faint as dust against the stars. Yet its lesson remains. Chaos is not an interruption in the story of the cosmos. It is the story itself. A reminder that existence unfolds not with certainty, but with sensitivity. That the smallest ripple can change the whole. And so, the science of chaos is also the poetry of the unknown. The fragile geometry of space-time, the unpredictable flare of a dying fragment, the ripple of uncertainty that spreads across the cosmic pond. These are not accidents. They are the nature of reality. The universe is not a perfect order, nor is it meaningless noise. It is something in between, alive with turbulence. And in that turbulence, humanity finds both fear and wonder. An atlas was a messenger of this truth. A fragment from beyond, breaking apart under forces invisible yet inevitable. A stone that struck the pond of space-time and rippled across human thought. It came, it shifted, it dissolved. But its meaning endures, and that chaos is not failure. It is the pulse of the universe itself. When the fragments of 3I Atlas scattered into the black, what remained was not clarity, but a field of questions. The telescopes had traced its sudden brightening. They had watched its unraveling. They had recorded the fading of its pieces into silence. But as with every interstellar visitor before, the data told only part of the story. What lingered was speculation, a landscape where science and imagination intertwine. The first explanation was the simplest. Natural disintegration. Comets in the solar system often fracture as they approach the sun. Sublimation of ice, the heating of volatile materials, the stresses of uneven outgassing, these can all destabilize fragile bodies. Some comets have even been observed splitting into multiple nuclei, scattering across the sky in pieces. Could 3I Atlas be nothing more than another fragile shard, undone by the same familiar processes? Yet this explanation left gaps. Its brightness flares were sharper, stranger, more erratic than expected. The disintegration seemed to unfold too violently, as though the object had been brittle long before sunlight reached it. To many, natural disintegration felt like a beginning, not a conclusion. From there, the debate expanded. Some astronomers turned to exotic compositions. Could 3I Atlas have been made of materials rarely seen in local space? In the years after Oumuamua's passage, one speculative idea gained traction, that it might have been composed of hydrogen ice. A body of near-pure hydrogen, drifting through interstellar space, would sublimate invisibly under sunlight. Its acceleration could have been explained by jets too faint to detect. Others proposed nitrogen ice, a fragment chipped from the frozen crust of a Pluto-like exoplanet. Both theories stretched the imagination, but both were rooted in the known chemistry of the galaxy. Hydrogen and nitrogen exist in abundance. Perhaps the rarity lay not in the elements themselves, but in their survival across the interstellar dark. If 3I Atlas were such a body, its fragility would be no surprise. A hydrogen iceberg would erode rapidly under solar radiation. A nitrogen fragment, once hardened by alien winters, could shatter under a warmer star. Yet the very existence of such a fragment would be profound. It would mean that planetary processes familiar on Earth, the sculpting of ices, the carving of crusts, the shattering of surfaces, occur across distant worlds. Each exotic composition would be a fingerprint of another planetary system, a glimpse into geologies and chemistries far beyond the sun. But there was another voice in the speculation. One that emerged in whispers with Oumuamua and has lingered ever since. The possibility that such objects are not natural at all. When Oumuamua's acceleration defied easy explanation, Avi Loeb of Harvard suggested it might be artificial. A probe, perhaps. A fragment of alien technology. A light sail drifting on the radiation of stars. His claim sparked controversy, dividing the astronomical community. Some dismissed it as unfounded. Others defended it as a valid hypothesis, no more speculative than unseen hydrogen ice. What mattered was that the data left room for questions. With 3I Atlas, the same shadow fell. Could its sudden disintegration have been more than chemistry? Could its flares have been signals, or the collapse of something built rather than born? Most scientists lean toward natural causes. The simplest answers are often the most likely. But in the space between probability and certainty, wonder thrives. Alien probe speculation is rarely about proof. It is about humility. It is about recognizing that the universe is ancient, vast, and indifferent to human timelines. Civilizations could rise and fall across the galaxy, leaving behind artifacts adrift in the dark. To consider the possibility is not to leap into fantasy, but to accept the breadth of what is unknown. Even if 3I Atlas was not artificial, its disintegration carried echoes of mystery. If it was a fragment of a larger body, where are the rest? Did it travel alone, or is it one of many shards seeded along the same trajectory? Could fragments still drift unseen, trailing faint debris through the solar system? Models of cometary breakup suggest that debris can persist for centuries, scattering into diffuse trails of dust. The thought lingers, what else has crossed unseen? Each speculation revealed less about 3I Atlas itself, and more about the boundary between knowledge and imagination. Science thrives on evidence, but its beating heart is curiosity. Between the data points where certainty dissolves, the mind begins to wonder. Philosophers have long reflected on this boundary. It is where myth once lived in the days before telescopes. It is where poetry still lingers, when the sky inspires more than calculation. In this space, speculation is not weakness. It is necessity. Without it, science would stagnate. With it, the human spirit stretches toward the unknown. Consider the comparison. Oumuamua, Borisov, Atlas, 3 messengers. Each behaved differently. Each defied the hope for a simple pattern. And yet, together, they painted a picture. The interstellar medium is alive with debris. The galaxy is seeded with fragments of planetary systems, each carrying secrets of their origin. Some are stable, some unstable, some barely coherent. To study them is to study not only astronomy, but probability itself. Theories of interstellar objects intersect with the broader question of cosmic abundance. If fragments like Atlas are common, then planetary systems across the Milky Way are violent places. Worlds collide, moons shatter, surfaces fracture, and in that violence, debris is ejected into the dark. Over billions of years, the galaxy becomes a sea of fragments, each a message in motion, each one a chance encounter waiting for discovery. And so the speculation expands outward, beyond composition and mechanics, into meaning. If the cosmos is filled with such wanderers, what role do they play in the larger story of existence? Some scientists have suggested they may even carry the seeds of life. Panspermia, the idea that microbes could travel on comets and asteroids, spreading across planetary systems, gains weight when interstellar objects are seen not as rare anomalies, but as constant travelers. If life could survive the journey, then perhaps Earth itself was seeded by such a fragment long ago. Others turn to darker reflections. If such objects can carry life, they can also carry extinction. A fragment striking a planet could erase ecosystems in a single blow. In this, interstellar objects are not only messengers of wonder, but reminders of fragility. The speculation, then, is not idle. It is philosophical. It forces humanity to reflect on its place in the cosmic order. For every telescope image, every paper published, the boundary of certainty remains thin. Science can explain the mechanics of light curves, the chemistry of ices, the mathematics of orbit, but it cannot yet answer why these fragments come when they do. It cannot yet predict what stories they carry. The Atlas was one more reminder. The universe does not speak in answers. It speaks in questions, carved into stone and ice, hurled across time. Each visitor is both data and mystery, both evidence and speculation, both science and philosophy. And so the debates continue. Hydrogen ice? Nitrogen crust? Natural disintegration? Alien artifact? Perhaps none. Perhaps all. The truth, like the object itself, has already slipped beyond reach. What remains is the reflection left behind, that the cosmos is larger than certainty, and that its mysteries cannot be contained within equations alone. Wonder grows in the space between what is known and what is imagined. It grows in the silence after the data fades. It grows in the humility of realizing that even with the most advanced telescopes, humanity is still only beginning to glimpse the depth of creation. Atlas was not only a fragment of another system. It was a fragment of truth itself, incomplete, unstable, and yet illuminating. A shard of the unknown, crossing through the realm of the sun, leaving behind not closure, but curiosity. Perhaps that is its true gift. Not the answers, but the questions. Not the certainty, but the wonder. A reminder that speculation is not the enemy of science, but its partner. That the boundary between the two is where discovery begins. And as its fragments drift silently into the void, the echoes of those questions remain. What else lies out there wandering unseen? What other stones are cast into the cosmic pond, rippling across uncertainty? And what stories will they tell when they arrive? In the depths of the night sky, where human eyes falter, machines extend their vision. Glass and mirror, lens and sensor, all built for a single purpose: to catch faint whispers of light across an ocean of dark. Without them, 3i Atlas would have passed unseen, another fragment lost to silence. With them, it became a mystery written in photons, briefly legible before dissolving again into the void. The Atlas system in Hawaii, the Asteroid Terrestrial Impact Last Alert System, was designed not for poetry, but for warning. Its mission is practical, urgent, to scan the skies each night for asteroids that might threaten Earth. 2 telescopes, stationed on volcanic slopes, sweep the heavens with automated precision, covering the dome of night in a constant survey. Their purpose is survival. Yet in April of 2020, they captured something beyond survival: the faint glow of a visitor from another star. Atlas had detected its namesake, a messenger whose meaning reached far beyond planetary defense. Atlas was not alone. Humanity's arsenal of instruments is broad, each with its own way of listening to the cosmos. Pan-STARRS, also perched in Hawaii, scans wide fields of sky with a vision deeper than human sight. It has become one of the great finders of comets, asteroids, and interstellar debris. Pan-STARRS had discovered Oumuamua years before, proving its ability to catch wanderers that slip almost invisibly between stars. Together, these telescopes form humanity's watch on the heavens. They are surveyors of chaos, their glass eyes reading the faint signatures of instability across the void. But their task is not simple. Interstellar objects move differently than those bound to the sun. Their paths cut through the solar system at sharp angles. Their speeds are higher, their time and range shorter. Detecting one is like glimpsing a shadow at the edge of vision, present for only a moment before it vanishes forever. Once discovered, larger instruments attempt to take over. The Hubble Space Telescope, orbiting above Earth's atmosphere, has captured light curves and spectra from distant objects with unmatched clarity. When Borisov passed through, Hubble was there to study its dust and gas. With 3i Atlas, astronomers hoped to do the same. But its disintegration complicated the task. By the time Hubble turned its gaze, much of the body had already fractured. Its light was smeared across space, harder to parse, harder to understand. The James Webb Space Telescope, though not yet fully operational during Atlas's passage, represents humanity's next leap forward. With its infrared vision, JWST is capable of detecting ices and compounds invisible to optical light. Had it been available, it might have measured the composition of Atlas in exquisite detail, distinguishing water ice from carbon dioxide, methane from ammonia, hydrogen from nitrogen. It could have given substance to the speculations, grounding theory in direct evidence. Its absence was a reminder of timing, that the cosmos reveals mysteries on its own schedule, not ours. Yet even with the best instruments, challenges remain. Interstellar objects are faint by nature. They do not linger. They do not circle back for another pass. They cross once, swiftly fading with each day. Astronomers must work against the clock, racing to gather photons before the object vanishes into distance. Every night matters. Every exposure is a fragment of a larger puzzle. Miss a window, and the data is gone forever. To capture these fragments, scientists turn to spectral analysis, the breaking of light into its component wavelengths. Just as a prism scatters sunlight into a rainbow, telescopes disperse the light of distant objects into bands of color. Within those bands lie fingerprints of chemistry, hydrogen lines, oxygen signatures, carbon compounds. From these faint imprints, astronomers infer composition, temperature, even the presence of dust or gas jets. For 3I Atlas, the spectra told a story of dust and volatiles, of an object unstable under the sun's warmth. But the story was incomplete. The signals were faint, often drowned in noise. The challenge of reading an interstellar heartbeat is that it beats too quietly, too quickly, too far away. The metaphor is inescapable. Humanity aims its glass eyes into the void, hoping to catch not only light but meaning. Each telescope is a stethoscope pressed against the chest of the cosmos, listening for rhythms too faint for ears. Each spectrum is a whisper, a heartbeat of a fragment older than Earth itself. And yet, as with medicine, the diagnosis is not always clear. The heartbeats of interstellar bodies are irregular, unstable, distorted by distance and time. Astronomers must interpret what they can, piecing together health from fragments of sound. The cosmos speaks, but in riddles. The difficulties of detection raise deeper reflections. For every Oumuamua, Borisov, or Atlas that is seen, how many others pass unnoticed? The telescopes scan, but they cover only part of the sky, only part of the time. The instruments are finite. The universe is vast. It is almost certain that countless interstellar objects slip by unseen, their stories lost in silence. This realization is humbling. Humanity sees only the rarest intersections, only the briefest glimpses. To think of the cosmos as empty is folly. It is full, teeming with debris, alive with fragments. But only a handful fall within the reach of glass and mirror. Only a handful leave behind data before vanishing. And yet, this is enough. Even fragments of information reshape understanding. Oumuamua challenged assumptions about what an interstellar object could be. Borisov confirmed that comets too drift between stars. Atlas revealed the fragility of such wanderers, their tendency toward disintegration. Each visitor, caught briefly in the net of telescopes, adds a thread to the tapestry of knowledge. The poetry lies not only in what is discovered, but in the act of discovery itself. Humanity, fragile and brief, builds machines to stretch its senses into infinity. It plants glass eyes on mountains, launches mirrors into orbit, unfolds infrared wings in space. It does this not for survival alone, but for meaning. To look outward is to look inward. To catch the heartbeat of a fragment is to hear the echo of existence itself. The tools of discovery are more than instruments. They are extensions of the species' longing. The Atlas system, scanning for threats, becomes a poet by accident, finding messages from other stars. Pan-stars, mapping asteroids, becomes a historian, recording shards of distant worlds. Hubble, staring from orbit, becomes a philosopher, seeing not only light but time itself. And JWST, with its golden mirrors, is humanity's dream given form, a machine that sees farther, deeper, clearer than any eye before it. Yet each instrument also reminds of limitation. Telescopes cannot capture everything. They cannot hold what slips too quickly, cannot measure what lies beyond their range. The cosmos remains larger than the machines built to study it. Perhaps that is why their existence feels sacred. They are finite windows onto an infinite sea. In the end, 3I Atlas was not solved by the tools of discovery. Its fragments scattered before full clarity could be reached. The instruments recorded what they could, light curves, spectra, orbital traces. But the meaning remained elusive. As with Oumuamua before it, the data left more questions than answers, and yet perhaps this is fitting. Discovery is not about closure, but about widening the horizon of mystery. Each interstellar object is not a solution, but an invitation. An invitation to build better instruments, to sharpen the ears of science, to listen more closely to the heartbeat of the universe. The telescopes will continue their watch. Atlas scans every night, prepared for what may come. Pan-stars opens its wide gaze to the unknown. Hubble still orbits, listening with its aging eyes. JWST has begun to unfold its vision, promising to turn the whispers of faint light into stories of clarity. Together they form humanity's dialogue with the cosmos. For in the end, the act of pointing glass eyes into the dark is more than science. It is faith. Faith that the universe is legible. Faith that its mysteries can be glimpsed, even if not solved. Faith that in the silence between stars, there are heartbeats waiting to be heard. Atlas was one such heartbeat. A pulse from beyond, caught briefly by telescopes before fading into silence. It left no certainty, only rhythm. No clarity, only echo. But in that echo lies the essence of discovery. The universe speaks faintly through fragments. Humanity listens with machines of glass and mirror. And between them grows the space where wonder lives. The night sky is often imagined as serene. Stars shimmer with quiet distance. Planets glide along their ancient orbits. The constellations appear eternal, painted on a canvas of stillness. Yet behind that illusion lies a universe alive with motion, collision, and risk. Interstellar fragments like 3I Atlas do not only stir wonder, they also raise a question older than astronomy itself. What happens when such chaos crosses the path of a world? Planetary defense is not a modern invention. Long before telescopes, humanity bore witness to fireballs tearing through the atmosphere, to craters carved into the earth. The scars remain. The vast basin of Chicxulub in Mexico, where an asteroid ended the age of the dinosaurs 66 million years ago. A single object, roughly 10 kilometers wide, altered the course of life on Earth. It reshaped ecosystems, extinguished species, and made room for new forms of life to rise. The cosmic dice had fallen, and with them the fate of an entire planet. In this context, the passage of 3I Atlas is more than a curiosity. Its chaotic instability forces reflection on the fragility of worlds. Most interstellar objects like comets and asteroids native to the solar system will never collide with Earth. Their orbits are steep, their trajectories hyperbolic. They come, they pass, they leave. Yet probability is not certainty. Each new visitor adds to the complex web of celestial dynamics. Even the faintest chance of collision evokes questions about preparedness. Astronomers who study planetary defense calculate probabilities with relentless precision. Surveys like Atlas and Pan-STARRS are designed to detect potential threats early, providing warning before an object crosses too close. NASA's Planetary Defense Coordination Office catalogs thousands of near-Earth asteroids, mapping their paths decades into the future. In 2022, the DART mission proved that humanity could nudge a small asteroid off course by striking it with a spacecraft, a first step toward active defense. These measures are rooted in practicality. But with interstellar objects, the challenge deepens. Their speeds are higher, their warning times shorter. A fragment like Atlas would offer only months of notice at best. To defend against such a visitor would test the limits of technology, strategy, and time. The chaos of Atlas also raises the question of debris. Its disintegration scattered fragments, some large enough to persist as bodies in their own right. Could such shards intersect with planetary paths? The likelihood of direct impact is small, yet the thought itself is sobering. Earth has survived eons of bombardment, its surface shaped by impact craters now softened by erosion and ocean. But Mars, with its thinner atmosphere and unhealed scars, tells the story more clearly. Its surface is littered with craters of all scales, frozen reminders of a world struck repeatedly by cosmic debris. When astronomers traced the orbit of 3I Atlas, some models suggested that its path brushed close to the domain of Mars. Not a collision, not even a near miss, but a passage that raised speculation. What would it mean if an interstellar fragment were to strike Mars instead of Earth? For now, Mars is a silent witness, but its fate is bound to the same laws of probability. A fragment crossing its orbit could excavate a crater, altering its surface in an instant. If humanity one day settles there, planetary defense will not be an abstract question, but a necessity for survival on two worlds. The consequences ripple outward into philosophy. The chaos observed in the skies above mirrors the chaos endured on Earth below. Civilizations rise and fall under forces not unlike those that scatter comets. Instability, unpredictability, the delicate balance of order and collapse. A fragment of rock crossing the solar system may seem distant from human affairs, yet its metaphor is immediate. It reminds that fragility is universal. Planets, like societies, are not invulnerable. Earth's history is written in the language of impacts. The moon itself is a monument to collision, born of a catastrophic impact between the young Earth and a body the size of Mars. The craters that pockmark its face are timepieces of cosmic violence. Life's evolution, too, has been steered by such events. Extinctions and survivals alike are tied to the whims of celestial debris. To reflect on 3i Atlas is to reflect on this inheritance. The universe does not merely surround life, it sculpts it. Speculation stretches further still. Could interstellar objects play a role not only in destruction but in seeding life? If fragments like Atlas carry ices, organics, even microscopic life encased within, their impacts may deliver more than devastation. They may deliver beginnings. Panspermia, the transfer of life between worlds, depends on such carriers. If so, then every impact is not merely an ending, but also a chance for creation. Earth itself may owe its origins to such a process, seeded by fragments from distant systems. But with creation comes risk. If a fragment can bring life, it can also end it. And therein lies the double edge of cosmic consequence. Interstellar objects are neither benevolent nor malevolent. They are indifferent. Their meaning lies only in their effect, and that effect is bound to chance. For civilizations that prize certainty, such chance is unsettling. It means that even with knowledge, even with preparation, the cosmos holds the power to surprise. This recognition fuels the urgency of planetary defense. The chaos of Atlas becomes a warning, a rehearsal of possibility. Its sudden flares, its disintegration, its unpredictable shifts, all serve as reminders that the sky is not fixed. It is dynamic, restless, alive with potential hazards. Humanity must choose whether to watch passively or to prepare actively. The difference between survival and extinction may lie in that choice. And yet, beyond practicality lies philosophy. To confront cosmic chaos is to confront human fragility. Civilizations flourish with the illusion of permanence. Cities rise, cultures evolve, technologies advance. But one fragment, one collision, can redraw the map in an instant. Just as the dinosaurs were swept aside, so too could humanity be humbled. This is not prophecy, but perspective. To acknowledge fragility is not to surrender to fear, but to recognize the truth of existence. The reflection extends inward. Chaos on Earth mirrors chaos in the sky. Climate shifts, pandemics, wars, each reminds that stability is temporary. Each reflects the same principle of sensitivity described in chaos theory, small changes yielding vast consequences. The cosmos and civilization are alike in this. They endure, they evolve, they collapse, they rise again. The universe is not static order, but dynamic turbulence. In this light, 3i Atlas becomes more than a fragment of rock and ice. It becomes a mirror. Its instability reflects the instability of life itself. Its unpredictability echoes the unpredictability of history. Its disintegration reminds of impermanence. Just as it fractured under forces unseen, so too can civilizations fracture under pressures not recognized until too late. Yet within this fragility lies wonder. The very fact that humanity can detect such fragments, trace their orbits, and reflect on their meaning is itself extraordinary. It speaks of resilience, of intelligence, of the will to understand. Tools of glass and mirror catch faint photons from across the void. Minds interpret those photons into stories of origin, risk, and meaning. The act of seeing transforms chaos into knowledge, and knowledge into reflection. And so the cosmic consequences of 3i Atlas are not measured only in probabilities of impact. They are measured in awareness. Awareness of fragility, awareness of resilience, awareness of the vast interplay between chance and survival. In its brief passage, Atlas did not strike Earth or Mars. It left no crater, no extinction, but it left perspective. It reminded that such outcomes are possible, that they have happened, and that they will happen again. The sky is not silent. It is alive with fragments. Each one is a dice roll across the span of time. Most fall harmlessly into the abyss. Some burn in the atmosphere as meteors, fleeting and beautiful. A rare few reach the surface, leaving scars that endure for ages. And in the rarest of rare events, an object comes not from within but from beyond. These carry not only risk, but also mystery. They expand the horizon of thought, forcing humanity to see itself as part of a greater story. Atlas was one such messenger. It fractured, it flared, it faded, yet its consequences endure, not in destruction, but in reflection. It asked the unspoken question, how fragile is life on a planet adrift in chaos? The answer, written in Earth's craters and Mars's scars, is clear. Fragile enough to be altered by a single stone, resilient enough to rise again. The cosmos does not promise safety. It promises only truth, and that existence is delicate, and that fragility is universal. In the turbulence of the sky, humanity sees its own turbulence mirrored, and in that mirror lies both warning and wonder. Long before the telescope, long before equations traced the arcs of planets, humanity looked upward and saw meaning. A comet blazing across the night sky was not just ice and dust. It was omen. It was prophecy. It was the hand of gods or the warning of ancestors. To every culture that watched, the sky was alive with messages. The stars were not silent. They were storytellers. Even now, in the age of spectrographs and orbital mechanics, fragments like 3I Atlas carry echoes of that ancient resonance. Science explains their orbits, their chemistry, their disintegration. Yet something older stirs when an interstellar visitor arrives. It is the sense that the universe has spoken, however briefly, across the gulf of space. Cultural memory is filled with these encounters. In ancient China, comets were called broom stars, sweeping change across the heavens. In medieval Europe, they were harbingers of war, famine, or the death of kings. For the Polynesian navigators of the Pacific, celestial phenomena were woven into the practical art of voyaging, but also into spiritual understanding of the ocean's immensity. In every myth and every story, the sky was a mirror. What it revealed was not only external but internal, human fear, hope, and longing reflected in cosmic fire. When Oumuamua appeared in 2017, the world reacted with the same mixture of science and wonder. Its strange, elongated form and inexplicable acceleration invited debate. Was it comet, asteroid, or something else entirely? The word chosen for its name, Oumuamua, scout, in Hawaiian, captured both fact and myth. It was a scientific designation, but also a story, a symbol of a messenger passing through. Humanity saw in it both data and mystery. Then came Borisov in 2019. This time the visitor was more familiar. It bore the hallmarks of a comet, with a tail of dust and gas streaming behind it. And yet even in its familiarity, there was meaning. To see a comet from another star system was to glimpse the universality of worlds. The processes that shape icy bodies around the sun were echoed elsewhere. Borisov was not only science. It was reassurance that the universe is shared, that other stars build the same fragile bodies, fragile lives. And then came Atlas. Unlike Borisov, it did not reassure. Unlike Oumuamua, it did not simply defy classification. It fractured, it flared, it dissolved. It carried chaos into the narrative, as though the trilogy of interstellar messengers was not a tale of answers, but of escalating questions. First came the scout, silent and strange. Then the comet, familiar yet foreign. Finally, the broken shard, unstable and chaotic. A story of deepening ambiguity, as though the cosmos had decided not to clarify, but to deepen the riddle. To science, these three objects are data points. But to culture, they are more They are the continuation of a dialogue that began when the first humans looked upward. They are reminders that humanity's hunger for meaning is as unyielding as gravity. Even with instruments capable of measuring spectra across light years, the impulse to see messengers remains. Perhaps it cannot be erased, because it is woven into the act of perception itself. An atlas, in this sense, is not just an astronomical event. It is a mirror of the human gaze. Its chaos reflects humanity's own uncertainty. Its disintegration echoes the fragility of civilizations. Its interstellar origin speaks to longing, the desire to know what lies beyond the sun, beyond the Milky Way, beyond comprehension itself. There is a paradox here. Science demands detachment. Theorists calculate orbits, estimate mass, simulate outgassing. The discipline insists on evidence, on rejecting speculation unanchored in data, and yet even within science, wonder grows. Astronomers who watched Atlas fracture could not help but feel awe. To see matter older than Earth unravel before their eyes was to confront time itself. To trace its orbit back beyond the sun was to touch distances so vast they silence language. Even within data, myth persists. This is the boundary where knowledge and imagination intertwine, where science measures fragments and philosophy asks what they mean, where telescopes detect brightness flares and the human spirit senses a message in the chaos. Perhaps this boundary is not a weakness, but a necessity. It is where wonder lives. Without wonder, science would be sterile. Without science, wonder would be empty. Together, they give meaning to fragments that would otherwise pass unseen, and perhaps this is the true message of Three-Eye Atlas and its predecessors, that the universe is not silent. It speaks not in words, but in stones hurled across time. It speaks in messengers that brush the sun's light and then vanish. It speaks in fragments that arrive unannounced, unpredictable, uninvited, yet profoundly transformative. Each visitor is a syllable in a language older than stars, a reminder that the cosmos is alive with dialogue. For those who see only silence, the interstellar void is empty. But for those who watch closely, the silence is filled with fragments, whispers, questions, echoes. Oumuamua whispered of possibilities unimagined. Borisov echoed the universality of worlds. Atlas questioned the very stability of matter itself. Together they form a trilogy, not of closure, but of conversation. The universe is not finished speaking. These were only the first words. Cultural resonance ensures that humanity will always interpret the sky through both science and story. In the disintegration of Atlas, some see only sublimating ice. Others see metaphor. Both views are true, for the object was both physics and symbol. Physics explains how it fractured. Symbol explains why it matters. Without one, the picture is incomplete. The hunger for meaning is ancient because it is necessary. To survive, early humans needed to read the sky, the cycles of seasons, the warnings of storms. But beyond survival, there was always something deeper. A need to understand not only how, but why. That need is not faded. It shapes art, religion, philosophy, science. It shapes the way humanity sees Three-Eye Atlas, not only as a fragment, but as a messenger. What message does it carry? That remains unclear. Perhaps it carries no message at all. Perhaps its arrival is random, the product of chaos and probability. Yet even randomness has meaning, for it forces reflection on chance itself. To exist in such a universe is to live on the edge of uncertainty. Atlas is a reminder of that uncertainty, embodied in a fragment of stone and ice. The reflection grows more profound when considering scale. Humanity exists for tens of thousands of years. Civilizations rise for thousands. Stars live for billions. Interstellar fragments travel across these scales, wandering between stars for ages longer than history. When they pass through the solar system, they bring with them the weight of time itself. To witness one is to glimpse not only space, but eternity. And so, the human gaze turns upward and inward at once. In Atlas, it sees both fragility and possibility. Fragility because a fragment can fracture in an instant, just as civilizations can collapse. Possibility because even in its dissolution, it connects humanity to the wider galaxy. It proves that the sun is not alone, that the Milky Way is not silent, that fragments of other worlds will come again. Perhaps one day telescopes will catch another, and another still. Perhaps hundreds more wander through unnoticed silent messengers crossing paths unseen. Each will add to the story, to the trilogy that has only just begun. Each will carry not only data, but meaning. For in the end, the universe is not empty. It is filled with fragments, and fragments are voices. They may not speak in language, but they speak in presence, in arrival, in mystery. The cosmos is not silent. It is speaking. Speaking in the only way it can, through the messengers it casts across the abyss. Oumuamua, Borisov, Atlas. 3 voices, 3 echoes, 3 questions. A trilogy of beginnings, not of endings. Proof that the dialogue has only just begun. And as humanity continues to watch, to measure, to interpret, the meaning of those fragments will deepen. For science will explain and culture will reflect. And in that reflection, wonder will grow. Atlas is gone now, dissolved into the dark. But its story lingers, not as an answer, but as a reminder. A reminder that the human gaze will never stop looking upward, that even in the silence of space there are voices, that the universe does not whisper to ears but to eyes. It speaks in fragments. It speaks in visitors. It speaks in the mystery of arrival and the silence of departure. And perhaps, just perhaps, it speaks not only to inform, but to transform. The universe is often described as orderly. Its planets revolve in predictable arcs. Its stars live and die by rules of mass and gravity. Its galaxies spin with patterns that can be mapped in equations. From this order has come the confidence of science, the belief that with enough patience, enough observation, the cosmos can be understood. And yet, within that order, eruptions of chaos persist. The sudden flare of 3I Atlas was one such eruption. In a system ruled by gravity's discipline, it broke free of expectation. It shifted. It fractured. It dissolved into fragments that defied the clarity astronomers sought. To watch such a body collapse was to be reminded that certainty is fragile, that even in the vast clockwork of space, unpredictability has its place. Albert Einstein once confessed that the most incomprehensible thing about the universe is that it is comprehensible. That so much of it can be mapped, predicted, and expressed through mathematics is itself a miracle. But in moments like this, the miracle is tested. Atlas did not conform. Its behavior mocked simplicity. It reminded that beneath the surface of order lies turbulence, a reminder that comprehension is never complete. Stephen Hawking offered another lens. To him, unpredictability was not a flaw, but a feature of reality. Quantum mechanics is built upon uncertainty, the idea that at its deepest level, nature does not provide certainties, only probabilities. In this view, the chaos of Atlas is not failure, but truth. The cosmos is not a perfect mechanism. It is a field of possibility, where instability is woven into the fabric of existence. To witness such a moment is to confront the paradox of being human. On the one hand, humanity is small, fragile, bound to a single planet. On the other, it has built machines that can capture the faint heartbeat of a fragment crossing from another star. It has crafted languages of mathematics capable of tracing trajectories across light years. It has developed the capacity not only to measure, but to reflect, to find meaning in chaos, and to let wonder grow in the gaps of comprehension. What does it mean that something insane can erupt in an ordered cosmos? Perhaps it means that order itself is not absolute, that what appears as chaos is not the breakdown of law, but the deeper expression of it. The fracture of Atlas was not lawless. It followed physics, even if those physics unfolded in ways unfamiliar. The unpredictability was not absence of rules, but a reminder of their complexity. Philosophically, this carries weight. Humanity has always sought permanence. In the stars, in the heavens, in the equations of science, there is the desire to believe that order is eternal. But the cosmos resists that desire. It reveals itself not as permanence but as flux. Stars are born and die. Galaxies collide and merge. Black holes evaporate over eons, and fragments like Atlas flare and vanish, carrying messages of impermanence. The emotional resonance is profound. For if the universe itself is unstable, what then of human life? Civilizations rise, flourish, and fall. Generations build, only to be replaced by those who follow. Existence itself is fragile, as prone to sudden shifts as any interstellar fragment. In Atlas's disintegration, one sees not only astronomy, but metaphor. A body, older than Earth, shattered in an instant. A reminder that nothing, not even stone, endures forever. And yet, there is also wonder. To witness such fragility is to recognize the beauty of impermanence. The fact that a fragment could travel across the galaxy for millions of years, only to unravel under the light of the sun, is not tragedy alone. It is poetry. It is the reminder that even in collapse, there is revelation. Atlas, in dissolving, revealed its nature. It spoke not in permanence, but in transformation. The closing image is one of silence. Telescopes tracked the fragments until they faded beyond detection. What remains now is absence. Atlas has gone, dissolved into dust and light. No trace remains within the solar system. Only the data, the memory, the reflection. It came, it flared, it fractured, it vanished. And in its wake, questions endure. Perhaps this is the universe's way of speaking. Not in answers, but in interruptions. Not in permanence, but in passing moments that force reflection. Oumuamua came and left without closure. Borisov arrived and behaved as expected, but only briefly. Atlas erupted in chaos, leaving a lesson in fragility. Each messenger came and vanished, carrying more questions than answers. Together they form a dialogue, not of certainty, but of wonder. Humanity stands as witness. Small, fragile, brief, and yet capable of wonder, capable of reflection, capable of aiming its instruments into the abyss and reading the faintest flickers of light. This capacity may be its greatest strength. The cosmos will always be larger, stranger, less predictable than imagination allows. But the ability to be moved by that unpredictability, to feel awe in the face of chaos, is what makes the act of watching meaningful. And so the story of Three-Eye Atlas does not end in science alone. It ends in philosophy. It ends in emotion. It ends in the recognition that the universe is not silent, even when it speaks only in fragments. A shard of ice, a flare of brightness, a path across the solar system. These are syllables in a language humanity is only beginning to hear. The final image is simple. A fragment from beyond, dissolving into dust under the light of a star, pieces scattered into the infinite dark, vanishing from sight. No answers, only silence. And yet within that silence there is resonance. For it is in silence that wonder grows. Atlas has left, but its questions remain. And perhaps that is the truest legacy of chaos in the cosmos, not to comfort, not to resolve, but to remind. To remind that the universe is vast, unstable, mysterious. To remind that existence itself is fragile. To remind that wonder begins where certainty ends. In the end, humanity does not command the cosmos. It witnesses it. And in witnessing, it learns that chaos is not the enemy of order. It is its companion. A mirror of impermanence, a messenger of mystery, a voice of the infinite speaking once and fading into silence.